Example 8, find each limits. So part A, you find the limit of 2x squared minus 4 all over x, 4x all over x plus 1 as x approaches infinity. Okay, so for this one, I'm going to use algebraic manipulation because graphing would be kind of difficult. So I'm going to divide each term by x squared. Then I'll go ahead and simplify the function. So this would become 2 minus at 4 over x all over 1 over x plus 1 over x squared. Now let's see if we can evaluate the limit. The numerator is going to end up being 2 because 4 divided by infinity, that's 0. So 2 minus 0 would be 2. The denominator is going to be 0 over 0. Now that's typically undefined, right? But when we're using limits, this is taking 2 and then essentially dividing it by a number that's getting smaller and smaller and smaller. If you did this on your calculator, you would notice that this would end up being infinity. So I'm going to erase this and write infinity here. Okay, part B, it's the same function. So I'm going to use this reduced function and then evaluate the limit as x is approaching negative infinity. So this time, the numerator would still be 2. The denominator is still going to be it's actually really difficult to try to evaluate what this is going to be, whether it's going to be, 0 where it's a really, really small negative value or a really, really small positive value. So what I'm going to do instead, I'm going to take this function and try long division. So x times 2x would give me 2x squared, and 2x times 1 would give me 2x. And then I could subtract here, and let's see, the first term would cancel out. Second term would be negative 4x minus 2x, so this would be negative 6x. I'm going to put plus a 0 here for a place value holder. And then I would multiply x times negative 6. So this would be negative 6x minus 6. Again, subtract. These would cancel out. This would become plus 6. So this would be plus 6 over x plus 1. So now, let's take a look at this limit of 2x minus 6 plus 6 over x plus 1 as x approaches negative infinity. From here, I think you can see, when we plug in infinity, this is going to be 2 times negative infinity, so that's going to be a negative infinity, minus 6, that's still going to be negative infinity, and that's going to end up being 0. So this is going to end up being negative infinity. So we would want to do it this way for this one, so we can tell that that's negative infinity. Let's look at example 9. Find the horizontal asymptotes and graph the function below by using limits. Okay, so we can figure out what the horizontal asymptotes are by taking the function, taking the limit of the function and letting x approach infinity. Also, we take the limit of the function as x is approaching negative infinity. So, first of all, let's simplify or algebraically manipulate this rational function by dividing each of these terms by x squared. So let's see, this would be the limit of 2 all over 1 plus 2 over x squared as x goes to infinity. So this would end up being, this is going to end up being 0 here, so this is going to end up being 2. So I'm going to have a horizontal asymptote at y equals 2. Let's see if anything changes here when you take the limit of this function as x approaches negative infinity. It's not, because we could use this manipulated function here and evaluate it as x is approaching negative infinity. This is still going to end up being 2. So we just have one horizontal asymptote.